All right, hello everyone. 622. How do shapes change? Dilations and similar figures. Have you ever wondered how different mirrors work? Most mirrors show you a reflection that looks just like you, but other mirrors, like the mirrors commonly found at carnivals and amusement parks, reflect back a face that is stretched or squished. You may look taller, shorter, wider, or narrower. These effects can be created on a computer if you put a picture into a photo program. If you do not follow the mathematical principles of proportionality when you enlarge or shrink a photo, you may find that the picture is stretched thin or spread out and not at all like the original. Today you will look at enlarging and reducing shapes using dilations to explore why a shape changes certain ways. Now, this is a kind of a long paragraph, and it kind of looks confusing. Like here, this part right here, if you do not follow the mathematical principles of proportionality when you enlarge or shrink the photo, you're like, what on earth are they talking about? What they're talking about is, for example, here, if you take this photo, and my wife and I were on vacation this summer, and this is one of the places in, where was it? Utah, I think it was, or one of those states. And it was a really big canyon. It was really cool. But if you put a program in a picture like this, or a picture in a program like this, you can just take it and click on this corner and see how it shrinks it naturally and it looks normal, right? If you press on one of these corner buttons here. But if I were to take this and go up like this, then I get really vertically challenged. Or if you go like this and go like, change it like this, then I look all funky, right? Okay, so that's what they're talking about. When you have a picture, you need to change it proportionally like this. Okay, that's what we're going to be studying and talking about today. All right, so problem 652. By the way, you do have a handout on this. It should be in your packet. If not, it is included along with this lesson, so you can print it out. Okay, you can pause the video and print it out if you need to, because it'll save you a lot of work if you print it out. Okay, so here we go. Lesson 652, undoing dilation. In lesson 621, you looked at dilations and multiplied each of the coordinates of a shape to change its size. Now you will explore how to undo dilation. Charlie multiplied each coordinate of the vertices of a shape by 4 to create the dilated shape at right, which I'll show you in just a second here. If Charlie multiplied to find its shape, what operation would undo his dilation and why? So here's the key word, is undoing. Okay, so if we were multiplying, and by the way, this is problem 652A, okay, so you're going to write down what I write here. How do I undo multiplication? Well, write this down. You undo multiplication. Write this down. I'm expecting this in notes. By doing what? Should be division. Okay, and we're not going to necessarily enter the y part because to undo multiplication, we divide. It's the opposite operation, okay? Then the next part says, using lesson 622A, the resource page which I was telling you about, undo the dilation on the graph at right, which I'll show you in just a second. Label the vertices on Charlie's original shape. How does a shape compare to the original or to the dilated shape? So here's what we're going to do. Here's our shape, and this is on your handout, okay? So you should have this on you right now. Otherwise, get it right now from the packet or print it out. But each one of these corners is called a vertex. And together, the plural of vertex is vertices. So we're going to find the coordinates of all the vertices. So please pause the video and write the coordinates of all the vertices and then unpause it and see if you're right. Okay, so here we go. This one here would be 4, -4. This one here would be 8, 4. This one here would be 4, 8. Careful with those numbers there. And this one over here would be -4, 4. Did you get those coordinates right? I hope so. If you didn't, please fix them right now because that's really important, okay? Now, we said that Charlie got these coordinates by multiplying all the coordinates by 4. So if I was going to undo them, and here's what I want you to write on your paper, okay? On the side on your paper, I want you to write the coordinates again. I want you to write -4, 4, and 4, 8, and 8, 4, and 4, -4. Please write this on the paper, on the left-hand side or on the right-hand side. I don't care. Either one is fine, but write them all down, okay? And if you need more time, if I'm going too quickly, you can always pause the video and wait and when I'm done, or when you're done, unpause it, okay? Now, if I multiplied something by 4 to get these up here, what would that something have to be? Well, this first one would have to be -1, 1. Why? What did I do? Well, I did the opposite, which we just talked about. To undo multiplying by 4, I divide by 4. So will you do me a favor, please, and divide all of those coordinates by 4 right now and write them down here below, right next to the one I just wrote. Cool? When you're done, unpause it and we'll compare it. Okay. So you should have, for the second one, you should have gotten 1, 2, and then 2, 1, and then 1, -1. And now I want you to go ahead and plot those points. So please put those points on the course. Now, here's the weird thing. It is not going to end up where you think it would end up, because you'd think it would end up right around here, right? Smack dab in the middle, wouldn't it? It doesn't. It ends up in a slightly different location, which is kind of interesting, okay? So please go ahead and do that. And when you're done, unpause it and we'll compare. All right. So here we go. You should have ended up here and here. Isn't that interesting? There and there. And then 1, 2, and 2, 1. So my big old shape started out, like this, okay? Because we dilated it by multiplying by 4, and that made it like that, okay? It made it stretch out, okay? And we ended up that way. So please be careful. When you dilate, it doesn't always end up or start where you think it's going to end up, okay? Or start. And that's where you should have had, or that's where it should have been, okay? Now, they do ask you the question, how does the shape compare to the dilated shape? Okay? And basically it's the same shape, but what's different? So write this down. The shape is the same. And you can write this on your handout or on your line paper, either way. This is this is 652B, okay? 652B. The shape is the same, but the sides of the original, this one in blue, the sides are what? The sides are 1/4 of the length. Okay? Which makes sense. If I multiply it by 4, the sides get 4 times bigger, don't they? So if I dilate, or if I divide by 4, they get 4 times, like 1/4 of the size. Cool? All right, good. That is the first problem. Second problem, 653. Alana was working with dilations. She wondered, what would happen if I multiplied each coordinate of a shape by 1/3? Now, again, this is on the second part of your handout, on the bottom part. On that part, graph and connect the points below to form her dilated shape. Be sure to connect them in the order given. Okay? So what I want you to do right now is I want you to graph those points on a graph and connect the points. And then we'll come back to this, okay? So you do it and then unpause it when you're ready. Oh, sorry. I guess it would help if I went back to, so there are the points, okay? So please plot these points on the bottom of your handout, on the bottom part of your handout where it says 653, okay? All right, here we go. So when you plotted them, you should have gotten -1 would be there. 1 -1 would be there. 1 2 would be here. And 2 -1. Did I do that right? -1 -1. -1 +1. Oh, I messed up, didn't I? -1 +1, which would be there. And then 1 2 and 2 -1. So it would end up like this. Is that the shape you got? I hope so. Okay, that's the shape you should have gotten, all right? Now we're going to go back here and, what do you think Alana, no, next part. Question A, here we go. Alana graphed this shape by multiplying each of her original coordinates by 1/3. What do you think Alana's shape looked like before the dilation? Make a prediction. So right now, I'm not going to answer that. You're going to write it down in your paper, and we're going to find out. So she got these coordinates. She got these. These are not the original, okay? What you graphed is what resulted from multiplying each of the original coordinates by 1/3. So what do you think the original shape looked like before she did that? and make a prediction. Write it down. And if you need more time, just pause it and write it down. But we're going to move on. On the same graph, or using, well, not the tool there, undo the dilation to show Alana's original shape. List the coordinates of the vertices of Alana's original shape. Okay, so we're going to go over here. Now, this time, we're writing these coordinates. These are the final coordinates here. So let's write these final coordinates. -1, -1. And you see I'm writing them a little bit lower because we're going to put the original ones up here, okay? -1, -1, -1, 1, 1, 2, and 2, -1. And my parentheses got there a little funky. They got a little big there. Now, this is the result of the dilation of what? Of multiplying by 1/3. So the question is, what would happen if I wanted to do the opposite? If I wanted to find out the original, if I wanted to go the opposite direction and find out the original, what would I have to do? What is the opposite of multiplying by 1/3? Okay? And the answer is, this one's kind of weird. You could say dividing by 1/3. You're right. Dividing by 1/3 is the opposite of multiplying by 1/3. Dividing by 1/3, by the way, is the same. This one's kind of the tricky one. It's the same as multiplying by 3. So in this case, instead of doing the multiplication division thing, we're multiplying by the reciprocal. So multiplying by 1/3 is the same as multiplying by 3. Okay? So going this way, multiplying by 1/3, the opposite of that is multiplying by 3, which means my original shape was -3, -3, -3, +3, 3, 6, and 6, -3. Okay? And how it ends up is kind of fun, kind of interesting. So again, be careful. It might not show or end up the way you think it is. So please go ahead and graph it and see what happens. When you're done, unpause it and we'll compare. Okay, when you graph it, you should have ended up with -3, -3, -3, +3, 3, 6, so 1, 2, 3, 6, whoo, all the way up there, and 6, -3, which would be here. So my shape ends up going, this right here in red was the original shape. And I multiplied everything by 1/3, it made it 1/3 of the size, okay? Each side. So what did you do to each coordinate to undo the dilation? In this case, we multiplied by 3. How did the shape change? And the shape, actually we're going to say the shape's sides, and we'll see why later. Shape size got 3 times larger. Okay? And do you think the shape, why do you think the shape changed this way? Okay, because, well, we're multiplying by 3, so it gets bigger. All right? Multiplying by 3 makes it bigger. Multiplying by 1/3 makes it smaller. All right? That's it for today. So that is all we've got. So make sure you've got that written down and have those notes. Oh, why do you think the shape changed this way? Multiplying by 3 makes values bigger. Okay? So tomorrow we will continue this lesson. So thank you very much for watching the video, and bring the notes tomorrow. Have your handout available as well, and I will see you tomorrow.